Hi friends, welcome to BSpice, Bala School for Process Instrumentation and Control Engineering. This is Ram Bala with you. In this video, we are going to talk about control valve types and applications. Hope you have watched my previous video on control valve refresher, which talks about the characteristics. If you have not watched, please pass some time to watch it. Okay, friends? And if you are watching this video for the first time, please subscribe so that you will not miss any important videos on this instrumentation aspects. Okay, friends, let's get started. Okay, so in this, we are going to talk about control valve types and applications. Okay, so I request you to watch the video throughout it so that you can get to know about control valve types. Of course, you know that, but the main important point is which type of valve you are going to use. The application point of view, we need to learn a lot in this. We'll learn a lot in this video. Okay, friends, let's get started. So basically, I'm going to talk about the control valve types in a form of a tree. Okay. So control valve, we have linear motion and rotary motion. Under linear motion, we have globe, we have gate, we have diaphragm, and we have pinch. Okay. Then under globe, we have globe, angle, and 3V. Again, the globe is classified as single-seated and double-seated. That's about linear motion. Then we talk about rotary motion. We have three types: ball, butterfly, and flag. So this is the gist of the control valve types. We will see the each type of valves, its functionalities and applications in the subsequent slides. Okay, friends, let's get started again. Okay, before going into the detail, I want to touch about the linear valve features and rotary valve features. So we'll talk about the linear first. Okay, friends, this is the look and feel of the linear type of valve. So if you can look at it, the flow path is tortuous. You can see here, the flow path is tortuous. Tortuous in the sense, it's like a twist and bend. That's the meaning. Okay, friends? Then low recovery. Okay, what is this low recovery? Because there is a considerable amount of flow stream energy is getting dissipated. Why? Because of the turbulence created by the contours of the flow path. So that is why it's low recovery. And the third feature is throttle small flow rates. As you can term it from the wording itself, it throttles small flow rates. Then it offers variety of special trim designs and it is suited for high pressure applications. Okay, so when we have a high pressure application, we can think about it linear bar. Okay, then flange type or threaded separable bonnet. Okay, friends, this is about the linear. Then we talk about rotary features. This is the look and feel of the rotary valve. Okay, so here if you can see, the flow path is very streamlined. You can see here it is very streamlined. Okay, then high recovery. Okay, friends, of course, more capacity and less packing wear. It's handle slurry and abrasives. So whenever you have a application for slurry and abrasive, you think about rotary bar utilization. Okay, friends. Then flangeless integral bonnet. Okay, and of course high rangeability. These are all the features of the rotary valve. Okay, friends. Now we'll go into the main part. This is about globe valve single seated. Okay, if you can look at this picture, you can have the look and feel of how the single seat arrangement is there. Okay, in this case, you can see the flow, large amount of force is required to drive the stem. So that is one of the factors we need to consider. Then here the fluid is pushing against the valve plug. You can see this is a plug, this is the seat. The fluid is entering like this. It is pushing against the valve plug. It keeps the plug off of the valve seat. So the valve seat is here and the plug is here. So it always keeps the plug off the valve seat because of the fluid flow direction. Okay, friends, it is used predominantly for tight shut-off applications. So, and of course, this is used for a small diameter application, meaning small line size. Okay, friends? Yes. And Predominantly, we use this for a large range of processes. Almost everywhere we use this kind of application, unless there is some, criteria, special criteria such as, the pressure drop or slurry application like that. Then in that we can go for a different type of work considering the process requirement. This is about the globe wall single seater. And of course, this is predominantly used in oil and gas and power applications. Okay, now we talk about globe wall double seated. So this is the look and feel. You can see here this upper seat and here lower seat. Okay, friends. So here it's driven with a small amount of force. That is a factor we need to consider. Okay, then no perfect closure and the possibilities of leakage is always on the cards, because here there is so many two flow path, here one flow path and here one flow path. So obviously the leakage is always on the cord, so we won't get perfect closure. So, and this is not suitable for application where tight leakage is necessitated. Okay, friends, in that case we can go for a single seated. Okay, so that criteria we need to keep it in mind. Okay, then large diameter, we can use this for large pipe size, and of course high flow and high pressure. So this is about the globe wall double seated. Okay, friends. Now we talk about gate valve. So this is the look and feel of the gate valve. As you can see here, the gate, right? Yes. So to predominantly this is used for on-off service. Okay, and suited for infrequent use of valve. Not very rare use, like infrequent use of application. We can use this valve. Okay, suitable for liquids and gas service. So, and predominantly deployed for slurries with entrained solids, granules, and powders. Okay, friends? Right. This is about the gate. Now we talk about the diaphragm valve. Okay. So diaphragm in the sense, okay. Yeah, you can see here, there is a flexible closure member. This is the body. Okay. So this is where the, what do you call it? The actuator is acting on it. Okay, so what is this? So diaphragm valve is a very simple in construction actually, and of course in operation. So the valve actuator is in contact with the inner membrane of the valve when it is in the open position. Okay, friends. So when the user desires the valve to be shut, okay, the actuator is pressed and the membrane, this membrane is pushed into the edge of the solid dam here, thereby closing the valve. Okay, friends. So this is the application and function of this diaphragm valve. So as I said earlier, the saddle or seat upon which the diaphragm closes the valves. Then it handles corrosive fluids and it's used for shut-off application and predominantly found in food, beverage, pharma, and biotech industries. That's about the diaphragm valve. Okay, now we talk about the pinch valve. Okay, friends? Right. So this is the look and feel of the pinch valve. You can see here also an elastomeric tubular member is there. Here, in normal conditions, the pinch valve is open. Okay, friends? Right. When air or hydraulic pressure is applied to it, to the valve, it pushes the elastomeric rubber sleeve, okay, creating a pinching effect. Hence this term, pinch valve, creating a pinching effect. So when the sleeve is fully pinched, the flow is restricted and thereby the valve is closed. Okay, friends. So the rubber sleeve in a pinch has a capacity or capability to trap the particles around it, thereby providing an excellent shut-off. Okay, friends. So this is a typical functionality of the pinch valve. So basically, this is what flexible sleeve allows the valve to close drop tight around the solids trapped by the seat or stuck in the crevices of globe, diaphragm, butterfly, gate, or ball valve. Because if you go for a globe or a diaphragm, butterfly, gate, so it will get trapped. But here that is not there actually, right? So that's a typical functionality of pinch valve. Okay, it handles slurries and is used for shut-off and predominantly used in cement, plastic, and ceramic industry, but not limited actually. Okay, friends? Right. So this is about the pinch valve. Okay. Then we talk about angle valve. It's very simple here. Like angle valve, the inlet and outlet port are perpendicular to each other. Okay. The fluid exits at the right angle to the entrance. This is the entrance and this is the exit. Okay. Then it's suitable for viscous fluids and fluids including solid bodies. Okay, friends, that's about the angle. Then we have a three-way valve. Okay, you can see here the three-way valve. And this, of course, used for a high flow capacity. And most importantly, it's used for mixing and diverting fluids. Okay. And of course, the high rangeability. Okay. Predominantly used in textile industries wherein, the mixing of colors or, the mixing of dyes are needed. Okay, friends. This is about the three-way valve. Okay. Now we'll go to the ball valve. So this is a typical look and feel of the ball valve. Of course, as we all knew, this is used for tight shut-off applications. So the minimum obstruction for flowing the media. Okay. Then high flow capacity, high pressure and temperature applications, hazardous and corrosive fluids. This is about the ball valves. Okay. Now butterfly valve. Okay. So the butterfly valve look and feel is like this. And this is used for high flow capacity. And most importantly, low pressure drop. Whenever there is a requirement for low pressure drop, we should deploy this butterfly valve. And is tight shut-off, predominantly used in steel, sugar, and textile industries. Of course, it's used in other industries also, water and power also. Okay, friends, depending on the application. Of course, we'll be talking about the application in the subsequent slides wherein you can have a specific, specific details over it, right? Thanks. Right. We'll go into plug valves. Okay, so the plug valve is a quarter turn rotary motion. You can see here the plug, it's a quarter turn rotary motion. Every quarter it turns, it's a rotary motion, right? Okay, so basically here the plug is tapered or cylindrical to stop or start the flow. That's the thing. So the disc is in a plug shape with the passage to pass the flow. So the board passage is in line with the flow in open position. So this typical picture shows the board passage is in line with the flow in open position. So the plug turned to 90 degree from open position and the solid part of the plug blocks the flow. So this is the typical feature of this plug valve. Okay. And importantly, whenever we need a quick operation or high pressure temperature service, we can deploy this plug valves. Okay, that's about plug valves. Okay. Now, very important stage of this video. Okay, application. First, we'll talk about globe valve. I have given an IEC reference also for your reference. IEC 60534-1-2005, clause 3.1.3. 3.1.1.3. Okay. So this globe is commonly used as a first choice. But except where allowable pressure drop is so low. This point we need to consider. When the allowable pressure drop is so low, we can't deploy globe valve. Okay, friends? And some features also. See, the gauge-guided globe valve should be avoided where fluid contains solid particles or coke formation. This we have to remember it. Gauge-guided are not suitable. This is the look and feel of the gauge-guide globe valve. Okay. And gauge-guided use for severe service application. What is the severe? Meaning it's anti-cavitation, noise reduction. So that's about the globe valve. Okay, friends, this is the application. Okay, we talk about the application of gate valve. Of course, we knew this is about on-off service, but not suitable for throttling service. Low pressure drop. Whenever there is a low pressure drop, we can deploy this provided there is a low frictional loss. Okay, in that scenario, we can go for a gate valve. And of course, this is bidirectional. Okay, friends, we can use on the both sides. That's the advantage of this gate valve. Okay, then we move on to diaphragm type valve. So the diaphragm type valve, it complies with the IEC 60534-1-2005, clause 3.1.1.1. Okay, is used for on-off and throttling service. Here the advantage is the stem leakage is eliminated completely. Okay, friends, and it is used for clean, dirty water and air service and slurries and viscous fluids. and predominantly used in food processing, pharma and brewing, etc. Why? It prevent contamination of flow medium. So that's why it's predominantly used in food processing. Okay. This is about diaphragm application. Okay. Now, pinch valve. Okay. Where and all it's used? So it's used predominantly when there is a abrasive and corrosive media, typically handling dry powders or discharge control for hoppers. Okay, friends? And the flow path is straight and minimum friction and used for quick opening and closing time and used in processing, food processing, medical, manufacturing, etc. So this is about the pinch valve. Okay. Then angle valve. Angle valve is in compliance with IEC 60534-1 2005 clause 3.1.1.3. Okay. Here, if you remember the previous slides, we have talked about the cork formation. So the angle valve is you deployed where the possibilities of cork formation is there. So predominantly used in hydrocarbon services, typical refineries or petrochemicals. Okay, friends, and used for erosive services. Slurries. What is erosive? Slurries and solid contaminants. Okay. High pressure drop across the valve. And typically flashing with an outlet velocity greater than 50 meters per second. Okay. So this is where we deploy this. Okay. And of course, this is predominantly used for cavitating services. This is about the angle valve. Okay. Then we talk about three-way valve. It's very simple for diverting and mixing services. That's it. Right? Right. Okay. Then we have valve valve. So valve is in compliance with IEC 60534-1 2005 clause 3.1.2.1. This is predominantly used for what? On-off service. Okay, friends? Right. Then we talk about butterfly valve. Okay. IEC 60534-1 2005 clause 3.1.2.3. Okay. So here this is used for high flow rate, yes, and most importantly with low pressure drop. So if low pressure drop means we should deploy butterfly valve. And of course, it's used for corrosive services where body lining is required. This is about the butterfly valve. Okay. Then we talk about the plug valve. Okay. Plug valve is typically deployed for on-off stop valve. Okay. On-off application. Okay, friends. Where and all it's used? Air, gaseous, vapor, hydrocarbon, slurries, mud, sewage. These are the areas. And additionally, it's used for vacuum, high pressure and temperature applications also. Okay, friends. I hope you got a very good insight on the control valve types and each of its applications. Thank you very much for your support. See you all with another interesting topic very soon. Until then, this is Rambala signing off. Thanks a lot. Bye-bye.